Okay, welcome back again. This time we're going to continue with 4.5 using graphs to estimate values, but this time we're going to do part 2. Okay, so instead of using, let's say, a graph of a car traveling, we're going to use just a plain old graph that we've always been seeing before, like this one. Okay, so now you have a line that is a linear relation. You can actually use this graph to also answer questions like this. Find y when x is equal to 2, or when x is equal to 3, when x is equal to negative 1.5. Okay, so what is the y going to be when x equals 2? Well, first of all, you find where x equals 2 is, which is right here, and you simply just move up towards the graph and find where, as soon as you hit that graph, you move left and y is equal to 4. Let's see, according to this graph. Let's try it again. When x is equal to 3, where is x equals 3? 1, 2, 3 is right here. Well, 3 is now beyond what we have, but it looks like it might actually be 6, because if you notice what's going on with the graph, for every as x increases by 1, y is actually increasing by what? By 2. Okay, so maybe the formula is actually, I'm just gonna play with this here, y is probably equals to 2x. Okay, and the adjuster may be, well, let's see, 2 times 1 is 2. Well, yeah, so y equals 2. Okay, y equals 2x. Okay, another graph doesn't quite look like that, but that looks like what's happening. But if we're going to use this graph as the estimate, we might as well use it to estimate. Okay, so when x equals negative 1.5, this time we got to go to negative 1.5, which is over here, the x. Move down, and it looks like our value is y equals negative 2 is what I got from here. Okay, again, this graph might not be super accurate because I made a crude one just using this loose leaf, which, yeah, you're not supposed to do, but it's just for notes sake, okay, and example's sake. So yeah, so that's what I used, and that looks like that's the estimate that we got. Okay, so that's what I'm going to go with for now. Vice versa, they can actually ask you find x when, given set of values of y, like this one. Okay, what is x when y is equal to negative 1? Well, okay, so this time we're going to look for y equals negative 1 first, and it seems like y equals negative 1 is down here. Okay, and so what is x going to be equal to? Well, again, a very bad graph, but it looks like from this graph, it looks like x is equal to negative 1. So that's what I'm going to get it. Okay, let's try it one more time, maybe a couple more times over here. When y is equal to negative 2, okay, y equals negative 2 is down here. What is x going to be? It looks like x is actually negative 1.5. Okay, so you can be asked questions like this on any old graphs that we've seen or done before. Okay, well, the last one is what is x when y is equal to 3? Okay, y is equal to 3. So we're going to look for 3 on the y-axis, which is right here, and then we move towards the graph, which is right here. So what is that x value here? It looks like I'm getting 1.5, 1.5, and the x equals 1.5. Okay. Again, that's how you use graphs to make those kinds of estimates on just plain old graph linear relation like this. And again, I do apologize. This might not be as accurate as it should be, and if it is, this line should actually cross through this origin, but it didn't, so don't mind it. You will have more accurate graphs on your assignment. Okay, but I hope that's a good enough good enough examples for you. That's enough examples for you. And that was part 2, and I wish you luck, and hopefully this video does help you out. Good luck, and I'll see you later. Bye for now.